Hello, welcome to my session, Intel SGX with SUSE Rancher and Istio Service Mesh. Today we're going to go over some Intel technologies, how they integrate and advance Istio Service Mesh, and how all of this can be managed and deployed with SUSE Rancher. On our agenda, I'll give an introduction and overview of Intel SGX. We'll go into Intel's Trusted Certificate Issuer, which leverages Intel SGX for Kubernetes certificate issuing. We'll do a brief overview of what Istio Service Mesh and service meshes in general are, and then we'll show how Intel technologies can be used to advance Istio security, how SUSE Rancher can be used to improve this deployment and management across many clusters, and then we'll go through a demo of these technologies. My name is Sam Attwood. I'm a DevOps engineer with SUSE. I'm focused on SUSE Rancher and the cloud-native ecosystem. So, Intel SGX. SGX stands for Software Guard Extensions. This is a mechanism that is built into modern Intel processors. SGX has been a part of a few families of processors at this point. Today we're specifically talking about SGX in Ice Lake and newer Xeons. So this is a tool for ensuring the integrity and privacy of secrets. This is both secret data as well as code execution. SGX leverages something called trusted enclaves, which are segments of memory that are stored encrypted, are only ever decrypted within the processor itself, and this allows for a very tight level of security for specific portions of your application. This is implemented as a part of the instruction set on the x86 processor, so there are specific instructions used for SGX applications. Fundamentally, SGX has a segment of memory set aside that is stored encrypted. That data is only ever decrypted on the processor itself. The benefit of this is that it protects your data even in the case of a compromised or untrusted platform. So if your host OS or your hypervisor or even your BIOS are compromised or not trusted, your data is still secure because it's only ever decrypted on the CPU die itself. This is, increasingly a concern in a very cloud-focused world where you often do not have full control of your stack. You don't run the hardware, you don't run the hypervisor layer, that sort of thing. So this provides additional assurances for security and integrity. SGX can be consumed in Kubernetes using Intel's device plugin. They also offer a device plugin operator, which allows for consumption of their range of device plugins. So enclaves are the fundamental building block of SGX. Your application is broken into trusted and untrusted components. In order to operate within the trusted enclave, you have trusted functions, which are your entry point into the trusted enclave. When the process begins, the enclave is created, and if a trusted function is called, then the data is moved, encrypted data is moved from system memory into the CPU, decrypted. Any operation happens all on the CPU, and then it is re-encrypted. The function returns back to the untrusted area, and the data is re-encrypted back in memory. So the encrypted segment is never stored unencrypted, is never unencrypted in flight. It is only unencrypted within the CPU itself. Now, the data is encrypted with a key that is generated and stored entirely on the processor. So if even if memory were to be read directly, the DRAM were to be read directly, the data cannot be obtained. It is stored encrypted, and the key is only unique to that system's processor. So it can't be decrypted on any other host. So Intel has built a tool called the Trusted Certificate Issuer. Now, this is for integrating with Kubernetes cluster certificate issuing. This works both with the native Kubernetes CSR resource, which was stable in 1.19. It also supports integration with Cert Manager, which is an extremely common method for managing certificate issuer within a Kubernetes cluster. Now, this leverages SGX. So the certificate authority that is used for signing all of the certificates for your CSR with Cert Manager is stored entirely, the private key is stored entirely within a trusted enclave. So you can have assurance that any keys that are signed by your CA within your cluster have the integrity and assurances of SGX. This allows for easy management and issuing of certificates for something like your service mesh, and it works just like you're used to or would expect, but it has significant advancements in security and integrity. So brief overview of Istio Service Mesh. Istio Service Mesh and Service Mesh in general are a network layer that operates between your microservices on your cluster. This offers a wide array of features from observability, traffic management, service discovery, security policies, load balancing, and a large number of other things. Fundamentally, generally, this is deployed as a sidecar proxy. So if you have let's say, a namespace that is marked for automatic injection of your service mesh proxy, any application pod that's deployed to that namespace will also receive a sidecar container, which is your proxy. This proxy can handle ingress, egress, inter-service traffic, and can comply with any policies you set there. So there are a lot of advantages, both for security and for logging and observability and everything else that was mentioned. Generally speaking, this aims to be transparent to the underlying application, so it doesn't require you to rebuild or restructure your architecture. Ideally, you can deploy it with an existing system without too much rebuilding, and it will add all these advantages. Istio is built on Envoy proxy, which is a CNCF graduated project. It's a very low footprint, high performance proxy built in C++. It's very popular in industry, so it's a very good, solid proxy, and it's cloud native focused. Istio Service Mesh is split into the control and data planes. The control plane handles the configuration of your deployment. It runs entirely in your Kubernetes cluster. It manages all of the configuration rules of the proxies. It can be used to dynamically update your proxy configuration based on any changes from the operator or changes to the environment. And it also manages the certificate issuing. The data plane is made up of the proxies themselves, so the sidecar containers running in your pods. It also can extend beyond your Kubernetes cluster to other external applications, but we won't go too much into that today. Generally speaking, Istio will use mutual TLS, MTLS, between all of the sidecar proxies. So even if your application is typically within the cluster, not using encrypted connections, this can add an encrypted layer, so all that traffic is encrypted even within the cluster. So every proxy gets a certificate that is signed by a trusted CA, and the MTLS negotiates between the proxies, so all that data is encrypted and trusted based on that central CA. And you'll see that the trust certificate issuer is what assures the security and privacy and trust of that CA. So how do we bring together the Intel SGX, Intel Trusted Certificate Issuer, and the Istio Service Mesh? If you're using the Trusted Certificate Issuer as an extension of Cert Manager or in combination with the native CSR resource, all of the certificates issued for your sidecar proxies for your service mesh will be signed by a CA that is controlled and managed entirely in an SGX trusted enclave. So the private key signing will always operate entirely on die on a CPU with SGX. What this means is that no matter who has control of the underlying platform, who has credentials on your Kubernetes cluster, no one is able to fetch your private signing key for your CA. So this means that the MTLS certificates issued to all of these proxies are extremely well trusted. There's no way that one could be impersonated. No one could sign a fraudulent certificate, anything like that. Typically speaking, if your certificates are stored within your Kubernetes cluster, they're stored as Kubernetes secrets. Kubernetes secrets functionally are a base 64 encoding of a string. So they are essentially stored in plain text. Base 64 encoding is not an encryption, right? So anyone with credentials to fetch secrets, anyone with access to memory, anyone with sufficient privilege on the system could fetch this private key. This is not true when you're using the trusted certificate issuer. If you go to fetch the secret, all you will see is the public key. The private key field will be empty. And anytime the service mesh requires that private key, it has to go through a trusted function call, and that entire operation will run in a trusted enclave on a system that has SGX. And you only need to have one system in your cluster with SGX for this to function. So bringing it all together with SUSE Rancher. SUSE Rancher makes it very easy to manage all your downstream clusters, manage deployments and configuration, The Intel Trusted Certificate Issuer will be available very shortly in the partner marketplace within the Rancher UI. This will make it easy to find, deploy, configure, update right from within your Rancher UI. This also allows for easy click-through deployment of things like the device plugin and device plugin operator. Rancher provides and maintains a Helm chart for deployment of Istio. So this allows for easy deployment and configuration of Istio to your downstream clusters. It also allows for some flexible configuration using things like overlays. We'll actually show this later on in the demo. If you want to manage many of your clusters as a group, or 1 to 1,000,000 clusters using a GitOps approach, you can use Rancher Fleet. This will allow you to deploy any configuration or baseline configuration to your clusters. So let's say you have some AKS confidential compute clusters running in Azure. You have some RKE2 clusters running on-prem on Intel Ice Lake Xeons or newer. You can leverage Fleet to deploy the same baseline configuration of the device plugin, the Trusted Certificate Issuer, and Istio to all of these clusters at the same time, revision at the same time, ensure everything is exactly matching how you want that configuration to be. So Fleet is very helpful for reducing toil and managing configuration and that sort of thing in this type of scenario. Let's go ahead and move over to our demo. All right, so for this demo, I'm going to go ahead and do a couple of deployments. We'll do a traditional deployment of Istio. I'll do a deployment using the Trusted Certificate Issuer, and then we'll compare and see some of the differences in both deployment and operation. So looking at the screen, we've got a pretty simple standard Rancher deployment. We've got a local cluster running on K3s. We have an AKS confidential compute cluster that's running on Azure. And then we have an RKE and RKE2 cluster that are both running as EC2 instances on AWS. So I'm going to hop over to our RKE2 instance here, and we're just going to do a standard deployment of Istio. And then afterwards, we will go ahead and deploy a demo application on top of that. So this is a pretty bare bones deployment. We've got our 3-node control plane, 3 workers, nothing really is deployed to this cluster other than the cluster operational pods themselves. So we'll hop over to our charts catalog here. We're going to use the Istio Helm chart provided by Rancher. So this is running Istio 1.13.3. We'll go ahead and install this. One change I am going to make is that I'm going to use a load balancer resource instead of node port for our ingress gateway. This is just to make it easier to demonstrate the demo application later on. I'm also going to go ahead and grab the kubeconfig file for this cluster because we will be doing some operations in the local terminal, and this will make that easier. So we can see here our SGO pods are already in a running state, so the Helm chart should be done in just a moment, and then once that's deployed, we'll be all ready to go. All right, and you can see that it just finished installing, so we can proceed. So just start out with, I'm going to demonstrate that when Istio gets installed, it creates a secret in the cluster that contains its certificate authority, both the public and private key. So I'm just going to demonstrate how easy it is to fetch this data and the private secret therein, and that anyone with sufficient privilege could very easily grab this. So you see you've got a CA cert.pem and a CA key.pem, the cert being the public key and the key being the private key. So just fetching the key here, we'll do a base 64 decode, which is not an encryption, just an encoding. And then we have our private key in plain text, which is how it's stored in the cluster in this scenario. And then we'll go ahead and grab some details just to show what this CA is configured as. We need to grab the cert, not the key for this. And we'll see now that the issuer here is cluster.local. This is the standard configuration for a CA for Istio. So now I'm going to proceed and deploy the book info application. This is just a simple demo application that Istio themselves provide for demonstrations such as this. We're also going to deploy an ingress resource for it, so we can demonstrate how to connect this application going through the Istio service mesh. So what we're doing here is creating a namespace for the application, and then we're adding a tag or a label to that namespace to say that any application pod deployed to this namespace should receive a sidecar container in that pod. So we're enabling Istio injection. Now we're deploying book info. And all of our pods should be coming up. And this YAML here is provided by the Istio project. It's just a local copy of upstream. It's not modified. And there we have our ingress. So if we hop back to our Rancher instance, we can look at our Istio install. By default, this chart also deploys Kiali, which is just a useful web UI for having some insight into your current Istio configuration. You can see here we have our book info applications running. We've got 4 applications running that Istio is aware of. Just some nice details you can dig into here and get some information on your deployment. So if we wanted to go directly to these services, you could click here and Rancher would actually proxy for you through the Kubernetes service, even though they're not exposed. But we want to go through the Istio service mesh through ingress. So I'm going to go ahead and grab that load balancer resource that we created earlier. We can see in the gateway YAML that was applied that the product page path should proxy us back to the product page application based on port. So we're going to go to the product page path, add our load balancer resource, and we should have our application pop right up. And there it is. So this is going through the Istio service mesh. It's a very standard deployment. Now, for every application pod for this application, there was an injected sidecar pod. So you'll see that there are 2 containers running per pod in this namespace. One of those 2 containers is an Envoy proxy for Istio, and each of those was issued a certificate that was signed by the Istio CA. So we're going to show, take a look at one of these certificates. We'll grab one from one of the proxies. So these certs were signed by that CA that, as I showed, it was very easy to fetch the private key for. So that's kind of what we're talking about here in terms of keeping that piece secure, because this is what adds to the integrity of the mutual TLS of these connections. So we're going to grab this is the CA that the cert was signed by. We'll grab that, and we're just going to demonstrate here that this is that same CA. You see that this is the issuer is cluster.local. So this is the CA that we were looking at just a few minutes ago. So now we're going to pop back. We're going to go to our AKS confidential compute cluster, and we're going to redeploy the same stack, but we're now going to use the trusted certificate issuer as an external provisioner for these certificates. And we'll see a little bit of a difference in how that CA is managed. So this is also a pretty basic deployment on this cluster. Nothing else is deployed to it other than the cluster operational pods themselves. So if we look at these pods, we've got a combination, but one thing that's nice is that we have the SGX device plugin already deployed for us to this cluster. So that was done for you. The rest of these are just standard Kubernetes or Azure AKS pods. So we're going to start off with applying some custom resource definitions, CRDs, that are made available from the Intel TCI repo. These are just required for the operation. Now we're going to go ahead and use the TCI Helm chart for deploying the certificate issuer. So that deployed very easily, but we actually want to have this in its own namespace. So I'm going to go ahead and very quickly roll that back, which is very easy to do, and we're going to redeploy it to a dedicated namespace rather than to default. So see, it cleans up very easily. So we'll go ahead and have Rancher make a namespace for us here. We're going to call it TCS Issuer. So one more resource that we want to create here is the TCS Cluster Issuer resource. This is what allows for the external provisioning. I've got a secret defined here, and I'll show you what that secret's about in just a moment. But we'll just create this very simple resource. So here you'll see you have a secret called the SGX signer secret. This is interesting. This is where our CA is, just like we were seeing in the previous deployment, but this one's a little bit different. So if we export this as JSON, you'll see that we have a cert and a key, but in this case, the key is actually an empty value. So in this case, it's because it's stored entirely in the SGX trusted enclaves. It's never made available in plaintext. It's never stored anywhere in plaintext. It's only in the encrypted memory and only ever decrypted on the CPU die that has the decryption key with SGX. So only the application itself can decrypt this, and only on that particular system. So we're going to go ahead and grab this CA like we did before, and just get a little information about it, just to show where it's coming from. And we'll see here that the subject is the SGX self-signed root certificate authority. So this is a CA that was generated with Intel SGX and is stored in the manner that was described. So one thing we're doing a little different here with our Istio deployment is we're going to use something called an overlay. There's a little bit of customization we're going to do to ensure that Istio is using our SGX cert authority for signing all of its Envoy proxy certificates. So we're going to go ahead and grab the public key of the CA here, which we of course can get, and then we're going to add it to this overlay file. And so we're going to use the same Istio Helm chart provided by Rancher, and it actually supports overlay files just like this, which is an Istio CTL mechanism. Istio CTL is kind of the modern way of deploying Istio, and the Rancher Helm chart leverages that tool. So we'll go ahead and copy this overlay file right into our Rancher deployment. Get this tab for the custom overlay file. All right, we're going to do that one other same edit, setting our ingress gateway to use a load balancer resource. We'll see now that our pods are almost done deploying. So in just a moment. All right, the installer is done. Helm chart installed successfully. And then we will proceed with deploying the exact same book info application. So we create the namespace, we label it for Istio injection. And then we go ahead and deploy our YAMLs here. So exact same deal as before. We've got our Kiali deployment. We can see we've got book info here. We got our 4 applications running, just like before. So I'm going to go ahead and grab a cert from one of the Envoy proxy sidecars, just like we had before, just to demonstrate that this was signed by our SGX protected certificate authority. So there we see now, rather than having the cluster.local CA, we have our certificate signed by the SGX self-signed certificate authority. So all the certs that are given to all the sidecar proxies are signed by this protected CA. I'll go ahead and grab the load balancer resource just before, demonstrate that going through standard Istio ingress works just as expected, but now with this protected private key of the signing key. And there we go. We have our application. So that's pretty much it for our demo today. Thanks very much for joining. Hope that was informational. And please enjoy the rest of the SUSECON content.